Okay, here goes the revision test for calculus. First of all, we got first principles, and the first one is a principal question at a particular point. So we write down the general formula, which is f dash a. In this case, it's at x equals 2, so we're doing it for f dash 2. Now to do f dash 2, wherever you see an a, you put the 2. So there's the 2 there. That a becomes a 2, that a becomes a 2. Now we have to substitute f of x. That f of x there is actually sitting up in the top, that's the function. So that function becomes 2x squared plus 3x, sitting in that bracket. And the f of 2, we can work out f of 2 by putting 2 into the function. So looking at that function up the top, it's going to be 2 times by 2 squared plus 3 times 2. Because if 2 is where x is, we put 2 there, and 2 2s are 4 times 2 is 8, 3 2s are 6, so total we have 14. And that's what we've got written in here. So that is your f of 2, and the x take 2 is sitting on the bottom still. Now we can just drop the brackets because all those terms are being added separately, and so we've got the whole top line there. Now the whole purpose of this is to cancel the bottom term out, because we've got this problem with the limit as x tends to 2. When x is 2, we get 0 on the bottom and it's undefined, so we have to cancel that out, and the way of doing that is to factorise this top. That factorises into 2 factors like this. It's first outers, inners, last in reverse. So we've got, if you expand this, 2x times x, they're the firsts, they give the first, 2x squared. 7 times 2, they give the last, 14. And then the middle term, 3x, has to come from the outers and inners. And the outers is 4x minus 4x, and the inners is plus 7x, giving the middle term plus 3x. Now we can cancel that x take 2 and x take 2, and so we're left with 2x plus 7. Notice when I cancel it, I put the proviso that x is not equal to 2, because we are dividing by x take 2, and if x is 2, we're really dividing by 0. Now we put the 2 in, now that the x take 2 is gone, and so you get 11. 2 2s are 4 plus 7 is 11. That represents the slope of the tangent at x equals 2. The next one is working out the slope function at a general point. To do that, we need the general function with the h's involved in it. That's the general function. Now we have to just replace f of x with x plus h incorporated into it. So instead of x there, we're going to replace it with x plus h, and that's what we've done down here. Square root of 3 take, instead of 2x, it's 2x plus h. That's that one done there. F of x plus h is equal to this one here. And then you got minus, and then we've got f of x, and that's replaced with f of x there. And we've got h on the bottom, h on the bottom. Now we have to multiply by the conjugate. When you've got square roots, you have to multiply by the conjugate. So here we've got a minus. We're going to multiply by the exact same bracket as the top, except we're going to have a plus. So we've got the minus here. This bracket here is exactly the same as that bracket there, but we've got alternating signs. The reason we do that is because when you multiply them, the outers and inners are going to go. But if we multiply the top by that bracket, we have to multiply the bottom by the same bracket so that we don't change the equation. Now doing the top line, if you multiply a square root by a square root, you get the same number that's sitting under the square root, so we just get 3 take 2x take 2h because the square roots go. So that gives that first term, so that when you multiply, I'll just use a different colour, when we multiply this first by this first, we get this, the square root drops. When you multiply the last term by the last term, you get this last term, and the square roots drop off, because it is this concept here, that if, for example, root 2 times root 2 is equal to 2, the square roots drop off. Opposite of squaring a square root, squaring and a square root is inverse operations. Okay, so the bottom denominator just stays, you keep that bracket there is still sitting here, and we've still got our h sitting there. Now we have to combine the top into one fraction. To do that, we're going to have to get common denominator, so we're going to multiply this by 3 take 2x on 3 take 2x, and we're going to multiply this one by 3 take 2x take 2h on 3 take 2x take 2h. Doing that, we're going to get a common denominator, and that is sitting here. There's the common denominator. So this whole square bracket here has become this whole square bracket here. Now multiplying the top here, 3 take 2x and 1, we get 3 take 2x. Multiplying this by 1, we get this here. And so now what you can see is the 3 cancels with the 3, the 2x cancels with the 2x, because that's a minus minus a plus, and we end up with plus 2h on the top. So in the next line you can see we have a plus 2h sitting there. We've still got this big denominator which is sitting there, but we've pulled the h up into there, and we pulled this whole bracket up into there, because when you've got a fraction divided by a number, the number comes into the bottom of the denominator. So that whole bottom bit there is this bit here pulled up into the h as well. So now we've reduced it down to 2 levels, and then we can cross off the h. We're actually dividing the top and the bottom by h, but we put the proviso that h is non-zero, and then we can put the 0 in, substitute it into the remaining h's. So the remaining h's is this one here and that one there. You can put it in there because it doesn't make the bottom 0, but it actually simplifies everything, and so we get our final answer sitting like that. Okay, so they are the 2 first principles. Now we're going to go on to the fast way of doing differentiation. The first one is set of indices. We're going to tidy up, make it in power notation. So x to the 6 stays the same, this stays the same, but this one here we want it in power notation. That's x to the minus 2. Now we do the derivative, where the number comes out the front. 6 comes out the front, you take 1 off the power. 3 comes out the front, making it 15, take 1 off the power. Minus 2 comes out the front, making it plus 2, take 1 off the power, minus 3. The next one we want to simplify first and then do the derivative. So x times x to the half is x to the 1.5, or x to the 3 on 2. Putting it up in power notation, it'll be minus 3 on 2. And now we do the derivative, so this comes out the front. 4 times 3 on 2 is 12 on 2, which is 6, and it's minus 6. Take 1 off the power, so it's minus 1.5, take 1 is minus 2.5, or minus 5 on 2. That's the power. The next one is a quotient rule. So you could let u equal the top and let v equal the bottom, and we do u dash, and we'll get 6x take 2, and v dash 3x squared, and you plug it into the quotient rule, which is u v dash take u dash v, sorry, the other way around, u dash v take u v dash. You do the derivative first, and then that's all divided by v squared. The next one is the chain rule. So the number comes out the front, you take one off the power, but you've got to follow it up by the derivative of the bracket sitting there. So that's 12x squared plus 6x. You can't forget this derivative here. Really the chain rule is dy dx is equal to dy du du dx, where u is this bracket. So you can see we're following it up at the end by the derivative of the bracket du dx. E is a quotient, but with a chain rule built into the quotient. So we're going to let u equal to the top one. That top one is our u, and we're going to let the bottom one equal our v. So u dash is 6x squared. Now v dash involves a chain rule, so the half comes out the front, take one off the power, follow it up with the derivative of the bracket, which is 2. And 2 times a half is 1, so it's just simplifies to that. And then we plug it into the quotient rule, which is u dash v take u v dash over v squared, which is sitting up above. This one here is a product rule, so and there's a chain also within the product. So we let the first term be u, that's this one, and we let the second term be, well they're not terms, factors. The first factor be u and the second factor be the v. The first factor, I've put it in a power notation. Instead of square root, we put it to the half. Then to do the derivative, the half comes out the front, take one off the power, and then follow up by the derivative of that bracket, which is 20x cubed. This one here is simple to get the derivative, and then we plug it into the formula for the product rule, which is u dash v plus u v dash. And the last question is a contextual question. So this is a roller coaster. This is the height of the roller coaster, where x is the horizontal distance from an observation platform. We need to find the derivative. Now the derivative, you take 2 out the front and give -4, take 1 off the power, and then followed by the derivative of the bracket, which actually is derivative of x, which is 1 there. Tidying it up there's our derivative. Of course the derivative of 5 is 0, so it doesn't affect it. And then it says draw a sign diagram of the derivative. So the sign diagram is when this is 0, it's going to be 0 when x is 3. So we put a solid line over 3 and we work out the signs. If you take a number bigger than 3, like 4, you have 4 take 3, which is 1. 1 times -4 is a negative. If you put something less than 3, like 0, 0 take 3 is -3. -4 times -3 is +12, it's a positive number. Now because this is a sign diagram of the slope, dh by dx, this is saying that it must be sloping up, this is saying it must be sloping down. And for that to occur, we're talking about a maximum. Minimums go minus plus, so they slope down and then slope up. So in part B, interpret the significance, we say it's a local maximum at that point 3 meters to the right of the platform. Now if the occupant is ejected 2 meters to the right, so that we know that 3 meters to the right it's a maximum. That means 2 meters to the right, it's a little bit down lower, so it's coming up like this, and that's the roller coaster ride. This is the height of the roller coaster, and we're going to eject it at that point, so the guy will actually fly in a straight line like that. So if he's ejected at 2 meters, what is the equation of his straight line? What's the equation of this dotted line? So here is the height of the roller coaster written again. Now we want to know what is the height when he's 2, so you put 2 wherever x is. Instead of x you put 2 there. If you work all that out, it'll give 3. So that means a point on the curve is 2, 3. So it's across 2 and up 3. That's the point on the curve, because that is the curve of the roller coaster. This here is the derivative of the curve, the slope. So we've already worked out above that it's minus 4x take 3. But the slope at 2, you put 2 where x is. So you put 2 here where x is, and if you can work that out, it'd be 4. So that means the slope of that dotted line is this slope here of that dotted line is 4. Now to get the equation, the tangent, you can use this formula: y take y1 on x take x1 equals slope. Or you could use y equals mx plus c. Another way, I've used this one here. So here's y take y1, x take x1. Notice this here is your y1, this is your x1. That's your point you're talking about, point 1. And all of that equals your slope, which is 4. And so that's your equation. You could just tidy it up by multiplying x take 2 over the other side. And so y take 3 is 4 times x take 2. And then you add 3. Opposite take 3 is add 3. So there's our equation. I mean, you could put it in mx plus c like this. You could expand the 4 in and make it 4x take 8 plus 3. So it's 4x take 5. So that's your slope 4, and that's where it cuts the y-intercept minus 5. How high above the roller coaster will the ejected occupant be? 3 meters to the right. So that's above the local maximum. We already know the roller coaster height is this equation. We want to know at 3. So when x is 3, we put 3 where x is, and that comes out to be 5. So the height of the roller coaster is 5. So coming back to that diagram up here, that means this here, that height of that maximum is 5 there. Across 3, up 5. But the ejected person is sitting up here, and we want to know what is the y coordinate of that person up there. That person is sitting on the equation line of the tangent line, so we need to use the tangent equation. Whereas this curve is the roller coaster. You need the roller coaster equation. So there are two equations there. And down here, I've got the 2 equations listed. So here's the roller coaster equation. Here's the ejected person equation. This one here is the original equation. This here, we just worked out above, is 4x take 2 plus 3. Now, if you put 3 into this one, that's the height of the roller coaster, but if you put 3 into this one, that's the height of the person, because this is the person equation, and this is the roller coaster equation. So you can see the person is 2 meters above the roller coaster, 7 above 5. So you can finish off saying the ejected person is 2 meters above the roller coaster when he's 3 meters to the right of the platform. Okay, good luck.